Good morning, everybody. Once again, we are into session number 12 of Cisco Certified Network Associate. And you all know that today is the last session. There are still some concepts remaining. There will be always. So do not worry about that. Can we cover everything? No, we cannot. But I can assure you that if you read now a lot of the thing, anything on internet regarding CCNA syllabus or maybe in CCNP, you will be quite confident and you can read them just like reading any article, right? Because I would say if you have gone through these 11 videos, your fundamentals are really, really strong, right? And if you are doing the labs also, this is going to add a lot of things on in whatever you are learning, right? So lab is definitely very, very interesting. If you just look the packet tracer, this is the software. I was not aware of the capabilities of this software. It is really, really awesome, right? So having said that, what we are going to cover today in next 2 to 3 hours, right? And here is the agenda. Many of the things are just a name for you right now, but believe me, if you understand why behind them, then they are going to make more then they are going to make more sense to you, right? We will be starting from where are we in the complete big picture. And believe me, if you can give me these 2 to 3 hours, you will be adding some cool things in you, right? Some cool concepts of networking. Those are going to be with you always. So I just need your 2 to 3 hours of full attention, concentration. And in the agenda, we are going to discuss access control list. What is the meaning of it? Yesterday, we talked about firewalls, right? You all know about it, that firewall can control access into your organization, or somebody wants to go out of your organization, or somebody want to access few things inside your organization, firewall can control that access. But all the time, uh, do I need to uh, get a firewall to do all these things? Do I need to purchase every time? No, there are some other mechanisms through which we can do this access control, although not as powerful as firewall, but access control list can do this thing. We will be talking about them, right? If we talk about a switch and a particular ports on that switch, if you have access of the physical switch, you can connect there your laptop and you can do whatever you want. What we can do here, we can include port security, right? Then we are going to talk about virtualization. I think you all know about it. If you are using Google Cloud, AWS, or basically any server where you are running multiple versions of operating system like Linux, Windows, you are using virtualization. We will be discussing about it for 5 or 10 minutes, not more than that. But interestingly, what we can do is we can virtualize our router also. What is the meaning of that virtualization? You'll talking about it, right? Then there are two concepts. I think everybody heard about them, right? DHCP and DNS. And believe me, these concepts are so important in making your in the complete understanding of this networking, right? Where DHCP comes into picture, where DNS comes into picture, because these are one of the important services which you need to have in your network. Even your home network, in which maybe if you go and work, if you are working in the from the in your house, or you're working from the home, that little network is also having these two things, DHCP and DNS. Believe me, right? And if you know the why behind them, you will be amazed to see that these are the things which are actually completing your networking picture. Once we are done with that, I will draw a complete picture of whatever we have learned. Let's combine everything, right? Because I believe that most of you understand that when you write cisco.com or www.google.com, amazon.com on your laptop, what happens behind the scene, right? If somebody is asking that to you, you can explain that in 2 to 3 minutes. And believe me, you can also explain the same thing in 2 to 3 hours. You must be thinking that is this guy mad? Believe me, I can spend 2 to 3 hours in this topic, that what happens when you write www.cisco.com on your laptop. What are the different pieces? So 2 to 3 minutes and 2 to 3 hours, there must be a lot of different. I have seen people talking about this thing, right? That many of the interviews, right, just got over on this question because they can check your knowledge only in this question, right? I'm not saying let's prepare for the interview. I'm just saying let's combine whatever we have learned, right, in a single page, in a single document, or in a single board. We will be spending, I'm not going to spend 2 to 3 hours for sure, right? Because I have already spent around 30 hours with you, so we have that solid base. I will try to complete everything in 10 to 20 minutes, right? Then there is an interesting thing with respect to DHCP relay, snooping. What are these? You will come to know about when we are done with the concept of DHCP, right? And then at last, we will be talking about quality of service. Punish will be giving you some idea about what is quality of service, right? And if I start from where we are, as you all know, that what we are trying to solve from the day one, we are trying to solve one problem, only one problem. How to make two computers talk. And that is why we are reading TCP/IP in depth, right? We have divided this complete problem into 5 different pieces, which is actually your TCP/IP layers. Number one layer is physical layer. We didn't talk about much. Second is data link. You all know about it. Third one is network. I think you should be pretty sure about it. We have talked about IP. We have talked about OSPF. And I'm pretty sure that OSPF is not a topic of only 1.5 hours. If you want to spend more time, you have all the resources in the world in Cisco. But believe me, Bridgewire is the best. So just open the OSPF course there and start reading it. It's a 23 hours, but amazing explanation of OSPF. Similarly, amazing explanation of BGP2, MPLS2, if you are more interested in that, right? Then we have literally talked about TCP with the example of Mr. Rahul and Miss Anjali, right? There is a sad story at the end because now Rahul knows that Anjali doesn't love him, right? Because now he understands that there was no transport layer, and that is why there was some miscommunication, right? But if you want to read the complete story of TCP and Anjali and Rahul, just have a look at TCP/IP course, right? At the last, we will be basically there is something called application layer. We haven't spent much time there because I do not believe as a network engineer, if you are not choosing security as your career aspirations, there is much thing to learn there. But yes, if you want to go ahead, just read about application layer too, right? But here CCNA talks about more data link layer, network layer, and transport layer. But you should not limit yourself. Believe me, networking is one of the most interesting subject after computer architecture I have read. Okay, so if you let's go to the first board straight away and let's talk about access control list. First thing first, as we start from this thing, right? We start from why behind any concept. So let's talk about why behind access list. Just try to understand. For now, this is just a name for you, right? So what is happening here? Let's consider a scenario. We have two VLANs or we have two networks. This is my network number one, the green network, right? And here I have network number two, the yellow network. You all know that the network can also be represented as the VLAN. So you can presume this is my VLAN 10, this is my VLAN 20. And if I want to make these two VLAN communicate, then of course I need to have a layer 3 device or maybe a layer 3 switch also. But in this case, I want to make it a little bit simpler. I'm using a different device, which is my router, which is R1. Interesting, right? Not that so, because we all know about it now. And what I have drawn here is this guy, right? This is the brain of this router, which is thinking and thinking, thinking loudly, right? So what it is thinking, we will let you know, but first thing first, let's understand the scenario. Suppose we have a particular host here in this network, which network 10.10.10.0, which is part of VLAN 10, and this complete network wants to talk to something here. And by the way, guys, VLAN 20 is the VLAN of all servers. You can see here, I have put a device here, which is basically my servers, right? You all know for the fact that in a particular enterprise, we need to have some applications, right? Just like the web application or FTP or DNS, DHCP, and so many things. And we run all those applications on the servers, right? Servers are more powerful machines than the laptop. You all know about it, right? And they have multiple interfaces too to connect them so that if something fails on a particular interface, then we can connect. But here I have only one interface, which is connecting this server to this switch. We can do that. Just like here we have laptops, here we have servers. It is as simple as that. So what is the thing here? This server, this one, right? I'm saying this is my server number 1, which is the finance server. Everything else, this is the web server, this is the FTP server, and so on, right? Right? So I do not want basically, uh, uh, okay, sorry for that. The scenario gets changed. This is the finance server. This is again another application server, which is very important to company CEO. This is again very important. This is again very important, right? And people in VLAN 10 are the people who has no relation with the server, means they do not need to access unless somebody is hacker here. They for their daily work, they do not need to communicate to this server, any server, right? But how do I control it? Because if I do not do it, because if I do not do anything, and suppose I know the IP address of the server, maybe this is 10.10.20.10, right? And somebody who is sitting here with 10.10.10.10, they can straight away communicate with each other, right? Why? Because this router is having the route for both the networks. The packet will be reaching here, router will be seeing its routing table, it will find that there is a connected route and definitely it is going to forward it here. And this guy can reach to this guy, means to finance server, to any server also. Now here is my problem. My company's CEO says, or anybody who is responsible for this networking infrastructure says, I do not want that people in VLAN 10 can access anything, any server in VLAN 20. VLAN 20 servers are the most prestigious to me. And more importantly, these people has nothing to do with these servers, right? Maybe the servers which they need are somewhere else in somewhere else VLAN, some else VLAN, right? So this is the requirement. So Mr. Rahul is here and he is listening as CEO because he has created this network. He's saying, I can do that. Can we buy a firewall for this? And CEO is saying, no, firewall is a costly device. Do you need a firewall for achieving this simpler task? Because Mr. Rahul, till now, he has attended just the CCNA training, all the 11 sessions. He is saying, I think yes, firewall is needed here. Then Mr. CEO is saying, please do some more research. I cannot buy a firewall so that you can do access control of this very basic task. You must be thinking, you must see, you must research. There must be something on the router itself which can do all these things, right? So here we have Mr. Rahul who is thinking aloud. He want to understand that his CEO has said that green VLAN should not be able to talk to VLAN 20. But there is another requirement also. It doesn't mean that this green VLAN cannot go to internet. There should not be any problem when these guys want to access internet. There shouldn't be any problem. But when these guys want to access this yellow network, it should be blocked right here. Interesting, right? By the way, guys, whatever I show you here in the normal terminology, we call these lines as traffic flows. And if you are becoming a network engineer, right, you should understand, because at the end of the day this matters a lot. If you can understand the traffic flow of an organization, of an enterprise, then you can do a lot of things there, because you understand the network now, how the traffic is flowing. And believe me, to come across this traffic flow, you need to spend many hours on these routers and switches. But if you complete this traffic flow of a particular organization, believe me, you can do wonders. You can definitely take that enterprise to the next level in terms of their networking infrastructure, right? So if I say enterprise, it means that you are responsible for their networking infrastructure. And believe me, sometimes it is a huge, huge infrastructure. I have seen, I think Dhaval can also echo that there are many organizations that are having more than 1,000 network devices. Sorry, more than 10,000 network devices, right? And you will come to know when someone from you is working in VCS, TAC, they will get to know definitely about these enterprise network, right? So what I'm talking about, I want to make you fully ready, right? That you do not get confused, you do not get intimidated with the huge number of all these devices. Okay, do not do that at that, because we all are humans. We can see one device at a time. We can see its configuration, and we can devise the traffic flow. So traffic flow understanding is very, very important, because CEO does not know anything about these switches and routers, right? How they are working, what is the routing table. He's just saying, I want VLAN 10 should get to internet, but it should not get to VLAN 20. And I want to do that without the firewall. I do not want to spend something with this trivial task, right? So I think you get the idea behind behind what we are trying to do here. So there is a way through which we can do. We can put something here in this router, which can definitely control this flow, and that something is known as actually your access control list, right? So why behind access control list is this situation, and let's see how ACLs are going to work, right? So again, everything, whatever you want to do on this router, at the end of the day, there is your configuration, right? And what you do in the configuration, you just log in into the router, you write enable there, you get this prompt, and then you write conft there, and then basically you start writing your commands, right? So there is something you can create on this router, okay, which can actually do the task required by your CEO, right? Interesting. So what is that? That is access list. Access list come into two flavors, standard one and extended one. So we are talking about here standard one. What is the meaning of it? But before understanding these access lists, you need to understand a concept which is known as wildcard mask. And you must be thinking that what is that? We have heard about mask, but what is the wildcard mask? So if we talk about it, then suppose we have a network which is 10.10.10.0/25, right? Not 25, 24. So this slash 24 can be written in another way, which is 255.255.255.0. Then you must be thinking, is this the wildcard mask? I would say no. This is the same representation. You can write slash 24 or you can write this. This is your mask. But the meaning of wildcard mask is if you invert all the bits of this number, right? Or if you can subtract this number from 255, whatever you get, you are getting a wildcard mask, right? Just try to do that. If we can subtract it from 255, the new number we are get is 0, here 0, here 0, here 255. It is as simple as that. So by simply flipping the bits of mask, we are going to get the wildcard mask. But what is the use case? The use case is that wherever this number is 0, wildcard mask says exactly match this. Wherever it is, this number is 1, right? It says, I do not care about it, right? So if I write down something, suppose if I want to match the starting 2 bits, 2 octet of this network, 10.10.0/24, right? I can say if I want to match exactly starting 2 octets, I will say if I want to match 0.0, then 255, then 255. Why? Because last 255 means all ones. And if there is a position where we have written down 1, it means I do not care about it. So this instruction, this wildcard mask is sending, this wildcard mask sends an instruction to the router that if I have written 0.0.255.255 for this IP address, it means that you need to match only the starting 2 octets, 10.10, and not the last 2 1. It is as simple as that, right? So suppose if I want to match this complete VLAN 10, and every host inside that, what I need to write? I need to write 10.10.10.0, right? And I would be writing here 0.0.0.255. I do not care what is the 4th octet. I only care what is there in the starting 3 octet. It should be matching, right? So if I write this statement, can you tell me, is it matching 10.10.10.130? Absolutely, it is matching. Why? Because wildcard mask says so, right? Wildcard mask is saying if the initial starting 3 octets is 10.10.10, I will be matching it. If I say another example, 10.10.10.230, am I matching it? Yes, absolutely, because starting 3 octets are 10.10.10. What if I say 10.10.20.0? Am I matching it? Absolutely not, because the 3rd octet is 20 and we have to match starting 3 octets. It is as simple as that. Wildcard masks say if it is 0, match everything, right? If it is 255, I do not care about that. It is as simple as that, right? So all the wildcard mask discussion is not going to over here. There are still a lot of things to learn. And one thing there is, which I would like you to explore more, is that the subnet mask basically can have ones and 0. And believe me, wildcard mask is also ones and zeros. But in the subnet mask, there is a continuous string of 1 and then continuous string of 0. It cannot be like this 1010 something, right? But wildcard mask can be like this. And how it is, I would like you to explore more on that, right? And this could be your, maybe if you want to learn more in terms of wildcard mask, because whatever I am explaining, it is very preliminary thing, right, about the wildcard mask. But there is still one thing which you need to explain more, which you understand more, that a wildcard mask can be like this, but subnet mask is always going to be in the string of 1, continuous 1, and then basically 0. For example, if I write /8, it means that the subnet mask is going to be all ones in the starting 8 octet, sorry, starting for first octet, and all 0, right? It should be the continuous string of ones and 0. It cannot be 1010 or 0011, right? Having said that, what I am going to, I think we understand the wildcard mask. to match anything. So what we need to do, if a packet is coming from here and it is going here, what should be the packet? The packet is going to be having source address of 10.10.10. The packet could be from any host, and that is what I am writing X here, right? And the packet can go to anywhere here, 10.10.20.10, or maybe it can go to the same packet can go to the source is going to be 10.10.10.x, and it can go to google.com also, right? I need to make sure that this packet is permittable. This packet should go and it should not go. It is as simple as that. So when this packet reaches here, I need to do something. And what I'm doing, I am creating an access list here. Access list syntax is very, very simple. I am saying that this is my first access list. What is the meaning? I can have this number or I can have any name. I could have written that a block VLAN 10 instead of this, right? So basically I'm taking the number access list 1, deny 10.10.10.0, 0.0.0.255. What it is matching, right? Leave the deny statement first. But if we consider only from here to here, what is it matching? It is matching that the starting 3 octets, if these are 10, right? Then I can do some action, right? And which is the VLAN which is going to have the entire, the starting 3 octets at 1, 10.10.10, which is VLAN 10, right? So basically here, whatever I'm matching, this is my source addresses. Source network, we also can say, right? So in the packet, basically through the standard access list, I can match the source, right? And I can straight away say deny that. It means that router is going to understand this access list because you have written the configuration of this router, and router is contemplating, thinking on this, right? That somebody has configured that access list 1 deny 10.10.10.0, right? So it will be seeing all the packet which are coming with the source IP address. And it means that all the packets which are coming from this VLAN, right? Why? Because any packet which is coming out from this VLAN is going to be having the source address in this range. It is as simple as that. But till now, I have just created this access list. I haven't applied it. This access list is saying deny anything which is coming with the source address of 10.10.10. It means that anything which is having in the source IP field 10.10.10, I do not care about the 4th octet. If anything is coming with 10.10.10, deny it, because I'm matching it the wildcard mask. 0.0.0 says starting 3 octets should match. And then on the second line of this access list, because this is again the, maybe you can say this, the number here is 10, here the number is 20. Why 10, 20? Because these are part of the same access list. In access list, when I am also saying that permit any means the access list basically is going to be evaluated from top to bottom. First thing first, the first statement, whatever is there, is going to be evaluated by this router, and it will see deny. I'm going to deny all the packets. I'm going to deny all the packets which are having starting 3 octet at 10.10.10, and I will be permitting anything else. It is as simple as that. But here is my problem. If I put this access list for all the traffic, then this router is going to say that whatever is coming with these source addresses, it is going to deny everything. I do not want that, right? I want this traffic flow to go, this to stop, right? So there must be some other mechanism through which can do, right? And that mechanism is that first you need to create this access list, this logic. If you create this configuration in the configuration file, believe me, it is not going to have any effect, because router's mind is going to say where I need to put this access list, and you are going to say put this access list on this interface. If anything is going out on this interface, just try to check that what is the source IP address of all those packets. If the source IP address match this range, then deny it, right? So if you consider router as yourself, something which is going out from you, right? That is the outbound direction. If the packets are going out with respect to this interface or with respect to you, that is the outbound direction. If something coming to you, that is inbound direction. What is going to happen if this host generate a packet, IP packet towards this server? This packet will be going inside this router. It means that if I consider this interface as 0/1 interface or 0/1 interface, then basically the direction of packet is inbound to you. And if this packet is going out here with respect to 0/2, the direction of packet is going out, right? So what you are going to do is you are going to put this access list, which is named as 1, in the outbound direction, of this interface. If you didn't get it, that is perfectly fine, because anyhow, I'm going to explain it once again, because this concept is very, very interesting and very, very important too. So this guy has generated an IP packet, right? And you have written this configuration here, and you are saying over this internet interface 0/2 interface, I will be putting this access list. What is the meaning of putting this access list? You are telling router, Mr. Router, I have created an access list for you, which is access list number 1. Put this access list on 0/2 interface in outbound direction. You need to write this also. You need to go into the 0/2 interface and you need to write IP access list, access group, right? The name of the access list is 1 in the outbound direction. What is the meaning? The meaning is router is going to see what packets are going into the outbound direction. Suppose this packet comes here, router is going to forward it into this direction because it knows where is VLAN 20 and here is a VLAN 10 IP address, right? But it is going to check that what access list is attached on this interface, and you have attached an access list number 1, which says if you see any IP packet which is having source address matching with 10.10.10, just deny it. Anything else should you permit? You should permit, right? And of course, if these packet from is this VLAN going into this direction, in the outbound direction, this router mine will see this packet. It will see the source IP address. It will block that right away because you have configured it. If you have any doubt, any question, please do ask. This is the entire working of how a standard access list work. But the important point is that the access list can have many statements like this: deny, deny, then permit, permit, right? It is going to be evaluated sequentially, and if a particular match occurs, then that packet is not going to go further down, right? For example, for this packet number 1, this match has occurred at the first statement, right? 10.10.10.0. It is going to be denied because you have written a work for the basically instruction for this router that to deny this packet because it is matching this one, right? So basically, if you see here, we are moving towards a logic into the routers. We can create logic into the router that what packet it should forward, what packet it should not, right? It is as simple as that. Mr. Dhaval, do we have any question from anybody?
No, Ishnu, not yet.
Perfect. That is fine. So there is another. So right now, basically, what we are matching here, we can match only source addresses here, and that is the little bit weakness of a standard access list. What if I want only that .10 host of here cannot communicate to .10 server of here, right? But the problem is through standard ACLs, I can only match the source IP address, not the destination. And I also cannot match the port protocol also, like TCP or UDP, right? So somebody has created extended access list also, which can match along with the source IP, they can match the destination also. It is as simple as that. And by the way, these different lines in the access list are known as access control entries. Of course, these are entries, entry number 1, 2, 3, 4, right? And by default, if you do not write anything, and if you put a access list here, by default, there is one statement which say deny everything, deny any, right? So do not make sure that you do not keep an access list which do not have any statement in it, because by default there is a deny statement, right? And I will leave this thing to you, that why they have chosen like this, why they have a deny statement at the end of the list. Because if you, okay, I'll leave it for you. Having said that, let's talk about more on the extended access list front. Now, what we are doing here is that we have a computer here which is having IP address 10.10.10, right? .10, right? Or basically what I want to do is now I want this complete VLAN. It should not be able to talk to 20.20 server, but it can talk to any other server. Previously, nobody from here was able to communicate to anything here, right? And by the way, guys, in previous board, there shouldn't be any problem with respect to internet traffic, and you should understand why, right? The internet traffic is going to come from here to here. Router is going to see that the destination is actually this interface. There is no access list I have put on this interface, and the traffic can go from here to here and can come from here to here. Similarly, on this side, basically the traffic can go from here to here, right? You must be wondering that although these hosts cannot initiate the communication, but can the server reaches here? Absolutely, server can reach here, no doubt, because you have put this access list in the outbound direction and it is matching the source as 10.10.10.0. Here the source is going to be 10.10.20.0 when the packet comes back, but this reverse packet is going to be blocked by this router, because now again the source is going to become 10.10.10. So anything, right? Interesting, interesting, right? So we are meeting all the requirements here, but now your boss says, extremely sorry, Mr. Rahul, I do not want that everybody should not be able to access the all the servers. But what I want is all the guys, whoever is here in this VLAN 10 should not be able to communicate to 20.20. And that is it. I do not care literally about that. They should not, they talk with this network or the server or this server. I literally do not care. But this is my finance server, and I do not want anybody to go and communicate to it, right? In this VLAN, right? So see, I'm talking about now standard. Extremely sorry. This is not standard at all. This is extended access control lists, right? You know that a standard list can only match the source IP address. And now the packet, suppose from here, it is going to, the source is going to be 10.10.10. anything. And suppose the destination, this IP address is 20.30, the destination is 10.10.20.30, right? Suppose this is packet number 1. Now suppose the packet number 2 is coming, which is this one. Again, packet source could be anything, .x, but the destination is here 10.10.10.10, 20.10, suppose, right? Your boss want this can go, this should not go, right? So now you are not taking decision. You are not only taking decision on the basis of source IP, you are taking the decision on the basis of destination IP also, right? Can we do that? Absolutely. With the help of extended access list, we can do that. So from 1 to 100, we can create basically from number 1 to number 100. This is the range for standard access list. And from 100 onwards, it is the range for extended. But till where? You need to see in the books, right? So I have written access list 101. When you write 101, it will going to open so many parameters for you, right? And suppose here my web server is running, finance web server, right? So I'm straight away saying deny TCP access to this server, right? So sorry, deny TCP access to anybody who is coming from this source address 10.10.10 match starting 3. And if it is going to only this, then basically deny it, otherwise not. Interesting, right? Suppose it's port 80. What is the meaning? The meaning is if somebody is coming from this source address, want to go to this destination address, and why I have written 0.0.0.0 because I want to match all the octets, because all the octets actually making its one IP address, which is 10.20, 10.10.20.20, which is this web server. And suppose anybody is running web server, and I am saying just deny port 80. Very, very interesting, right? And then permit anything, right? So if this packet is going to sorry, this is 20.20. So this packet is going towards the server, towards the TCP web server. This packet is going to be dropped, right? And of course, you need to put this access list here. It is as simple as that, right? But this packet, as it is going to 20.30, it is not going to be matched with the first statement. It is going to be matched by the second statement, which says permit any, and that the second packet will go, right? This is the second packet, this is the first packet, right? It is as simple as that. If you guys have any doubt, any question, please do ask. If you don't, let's move to the next board, where we are going to talk about port security. Very simple concept, but it solves a lot of problems. So let's first discuss why behind port security, right? But before moving further, Mr. Dhaval, do we have any question?
No issue.
Perfect. Everybody is quiet today. So let's take a poll. Till this time, anybody has any doubt in understanding access list, extended or standard? If you do not have any doubt, please raise your hand. I can see the hand raise. Okay, perfect. This is good. This is good. Okay, so now let's talk about port security. And we have a switch here, right? I think that if I draw this switch or host, then I strongly believe now that you can create your basically you have a picture in your mind that I'm talking about layer 2 here, right? Because the switch is into the picture, right? And I'm talking about switches, VLANs, and that is it, right? So just try to start making that picture. I have only one switch here, and this switch is having FA0/1 interface. No problems. And I have one laptop here which is having the MAC address, this one, A.A.A, suppose, right? This laptop is a legitimate user of this organization, whatever the organization we are running this network infrastructure is, right? And now what is going to, and if it is a legitimate user, then basically it can connect to the switch, and switch can pass it traffic to wherever it wants to go, maybe the router, maybe the internet, or whatever, right? But suppose now this guy is not here, right? Suppose this guy is not here, and anybody else who is having the laptop but not the employee of this company, if it can connect to this port, right? Maybe this is in VLAN 10. What is going to happen? This guy also will be getting the same access, right? Although there are a lot of new technologies coming which says you need to authenticate, which is .1x. If you are going to in the security, you will be reading about it, right? This is not .1q. .1q was for trunk. This is .1x. .1x is for authentication. When you join a particular network, you will be authenticated whether you are a part of this organization or not. If you're not, you won't be, means the system is not going to give you the privileges to access this network. It is as simple as that. So, but under normal conditions, if you have been connected with the wire, this employee has gone, right? He's at home now. Somebody else come with their laptop, and if they want to connect their laptop on the same port, it is going to be a problem, right? He can get all the access, right? So before .1x and before uh, new technologies, we had something which is known as port security. Extremely sorry for this spelling mistake. This is the port security, right? What we do in port security, right? Let's see on the next board. So basically, we can configure this switch. Again, when I say config, it means you need to log in into the configuration mode of the switch, right? And what we need to save, we need to save this, we need to safeguard this FA0/1 interface, right? I can literally write in the configuration of this switch that only one MAC address should be allowed on this port. Interesting. And what should be that MAC address? It should be A.A.A. But the management in such case is very, very difficult. Very, very difficult, because you need to understand that you should be collecting all the MAC addresses. There is no automation here, right? But what we can do is, whoever connected first, I will let it connect. But if somebody else connect, then I will be denying, right? So it means that switch is learning the MAC address, and of course switch learn the MAC address, right? So first time whoever is connecting, suppose this is my employee, and if it is connected with this wire, this switch is going to learn that FA0/1 port is connected with A.A.A, and this port can only be connected with this MAC address and nothing else. It means that if this guy wants to connect over FA0/1, he will be denied. He will be the system or the switch will be saying that your MAC address is not A.A.A. Previously, somebody was here with A.A.A, and I have learnt that, right? We call such learnt address as sticky address, because those are going to stuck there on FA0/1, and nobody else can come with their MAC address on the switch port and get hold of this switch and can pass their traffic. So this is the whole soul theory behind port security. Very, very simple, really easy. The configuration is again not that, you know, that past Ethernet 0/1 mode access, you all know it's a part of access VLAN. Anything. If you want to enable this port security, you need to write switch port security, and by default there is going to be only this switch is going to permit only one MAC address per interface. Switch port security, because this is the feature we are configuring, and then I am saying MAC address sticky. Sticky means whatever the first MAC address you learn, it should stick with you. You must be wondering that what if this guy has come before this guy, right? It can happen, and if that happens, then basically this guy will be sticking, right? And that is why this is not scalable model of securing your switch port, right? But yes, this is part of CCNA syllabus. Again, this is not post security, this is the port security. But overall, if you configure this, and if this device is connected later, it won't be given access. As simple as that, right? So this was your port security. Let's talk about the next concept, and very, very interesting concept, right? So where are we with respect to current thing, right? We are learning some of the nitty-gritties, whatever the concepts which remain, we are talking about it. Those are like access list comes under security, right? Why? Because over this router or on the switch, you can place these access lists and control the desired behavior without installing any firewall, right? Port security is another security feature which you can have on the switch port. But what here, Mr. Dhaval, I would like to take a pause here. Can you tell me that? Is there any question?
No, Vishnu.
Nice. Okay. So what is the meaning of virtualization? So if I take an example of your laptop, right? Believe me, this is one of the most important thing in today's world because everybody is doing this virtualization. Previously, we means if you go back 10, 12 years back, everybody was having a physical machine, just like you. Take an example that we have this laptop with us, given by Cisco, pretty neat laptop. Somebody can have Mac or Windows, right? Suppose I have this Windows laptop here. What I'm actually doing, first thing first, Windows is the operating system. This is the software, right? You all know about it. This software is actually controlling the hardware. What is the hardware? Oh, this is created by Lenovo, suppose. And of course, inside, if you can see that there are a lot of things. Basically, you are going to have CPU, you are going to have network interface card, you are going to have RAM, random access memory, hard disk, and so on, right? Maybe you have the speaker here, so many hardware, right? Who is controlling all those hardware? This operating system, right? And it is very easy. But I'm not sure how many of you have thought about the philosophy of these computers, right? As I mentioned, that after computer architecture, the most fascinating thing which I have learned is networking. I do not want to go a little bit deeper into that, but I would say just try to think what is a CPU? CPU is just a metal, right? And then you are here, you are giving some instruction to this guy, and this metal at the end of the day, everything, whatever this operating system or you say through the command line, it is going towards this metal, and this metal is executing that. It is very, very fascinating thing, right? How it does that, right? And you must be thinking very easy. We give command in the form of ones and zeros, and this computer execute, right? But how that entire thing is working? Believe me, one of the most important invention done by human being. How we are making sure that a particular piece of metal is actually working, and it's all about rearranging and arranging your ones and zeros, right? But let's not get too philosophical about it. I just wanted to say this is one of the most uh, fascinating topic for me. I'm not sure for you, but yes, what we do here is over this hardware we just install Windows, which is the operating system and which governs this hardware, right? But on a particular hardware, we install either Windows or Mac, right? And this was the case till means if you can say 10, 12 years back, and somebody came with another thing, right? Somebody came with another concept, and it says no, on even a single hardware, I can run multiple operating system. This is very, very interesting, right? Means this laptop, this Lenovo laptop can run Linux, can run Windows, and it also can run Mac also. It is very, very interesting, right? Because at the end of the day, Mac is also running on a hardware, Linux is also running on a hardware, Windows is also running on a hardware. So somebody has proven this, right? That they need extra piece of software for that. What is the meaning? The meaning is suppose we have a server. This is a pretty powerful server. It is having 128 CPU, not 1, 2, 3, 128 CPUs, right? 512 GB of RAM. When I bought my first computer, the hard disk space in that was 10 GB. I'm not talking about RAM, right? Here, RAM is 512 GB, and maybe right now you can see the server which are having 1 terabyte or maybe more than that RAM, right? And then it is having 12 terabyte of hard disk. It is having only two NICs, NIC number 1 and NIC number 2. Now see the powerful. What we are doing is instead of seeing see the power of this server and a new version of operating system, what we are doing is we are taking this server, but we are not installing Windows operating system or Linux operating system or anything on else, right? On this hardware system, I am installing another piece of code, another piece of operating system which is known as hypervisor, right? Just a name, but it's an operating system once again, right? So on a bare metal on hardware, I am installing first thing first this operating system, and we call this operating system as hypervisor. This is not running Windows, not running Mac or Linux, right? No. But what we can do once we install that, now we can install different flavors of operating system. Maybe we can create one machine which is running Windows, another machine which is running Linux. This Windows machine is getting 8 CPUs, 16 GB of RAM. This Linux machine is having 32 CPUs, 64 GB of RAM. Interesting. From where we are taking all these things, because physical server supports it. But previously, if I install Windows operating system is going to take everything, 128 CPU, 512 GB RAM. Now, instead of running one machine, I can run multiple machines here, right? And interestingly, over this Linux machine, I can define two NIC, and in Windows machine, I can define one NIC. And overall system supports only two NICs, right? Who is controlling this? That at the end of the day, the traffic is going to go over these NICs, right? Network interface card. Maybe it is connecting with the switch, right? At the end of the day, it is like this. But who is making sure that this guy, the Linux host, is going to get these two, both the NICs, right? And then Windows host also get one NIC, right? So basically, you are sharing the resources, one resource among multiple machines. This is the responsibility of this hypervisor or operating system. Previously, what operating system was doing for us? It is actually managing the hardware resources for us. But now you can say there is one operating system which is known as hypervisor. It is taking care of us. Although we have only two NICs, I can run another virtual machine and then I can have two NICs there. And hypervisor is going to take care, because at the end of the day, packets are going to come, and at the end of the day, those can go from here or here. We can share the hardware. We are sharing the hardware amongst multiple virtual machines. So basically, whatever these machines are, these are known as virtual machines. So previously, when I was giving example of a data center, right, the physical data center of Mr. Dhaval Patel, and Rahul has created network for it, and they were moving it in the cloud. The cloud guy says that I already have huge servers. If you have your website, you want to run your website, just tell me and I will run a virtual machine for you, and you can install your website or here and anybody can access it. It's as simple as that, right? Very, very easy. Similarly, if you go 10 years back, Cisco's routers actually comes with only physical hardware. We have a physical hardware, we install operating system, Cisco's operating system, which is Cisco's iOS, Internet operating system, or other flavors, XC. We install on top of it and we sell it, right? But believe me, now companies want, because servers can be virtualized, right? You can have Windows server, we can have Linux server inside a one physical server, right? Why can't we have routers also virtualized? Interesting, right? I can see that there are cloud services router range of Cisco, which is doing all those, whatever we have learned. And these is your virtualized platform. If you understand SD-WAN, if you heard about SD-WAN, the edges of SD-WAN are also your virtual machines, right? So whatever we are seeing here, these are your virtual machines. Having said that, this topic can be discussed maybe 5 hours, 10 hours. I can talk and talk about it. But again, you all are going to be here. I will be here maybe sometime else, right? Maybe some other time we can discuss it. Let's leave it here for now, but we will see that we can do some virtualization inside a physical router also. Very, very interesting, right? What is the meaning? If you consider layer 2, if you consider a switch, what exactly happens there? If you remember, suppose I have a switch of 8 ports, right? Port number 1, port number 2, 3, 4, 5, 6, 7, and 8. What I was doing there is, if I include these 3 ports in a particular VLAN, then basically these 3 ports become part of the VLAN, right? If somebody is connected here and sending ARP, it cannot go outside second and third. And I can do the same thing. I can create another VLAN here with 6, 7, and 8, right? This is my VLAN number 2. So maybe this is 10, this is 20. And you know the concept, right? Now the ARP cannot go from here to here. Don't you think that I am successfully, I was here, I am successfully able to create 2 switches out of 1 switch, or maybe 3 switch. Maybe this is another VLAN, right? Interesting. So one switch is of having only 3 ports, 1, 2, 3. Another switch is having only 2 ports, 4 and 5, and another switch is of having 6, 7, 8. We call all of these as virtual, right? Because the switch is physical and we were able to create 3 switches out of it, right? This is dealing with VLAN network number 10. This is dealing with network number 20. This is maybe 30, right? Maybe you have created VLAN 30 here. One switch can be virtualized into 3 different switches. And if I want to communicate amongst these 3 switches, or whoever is connected here, I need to have one layer 3 device, which is the router. You all know, or maybe the layer 3 switch also. You all know. But can we do the same thing in case of router 2? If we can do that, what is the use case? Believe me, why behind virtual router is going to take too much of a time, right? Which is not required CCNA level, but I would again say, because I get some of the feedback that it would be great if we can go into deeper for some concept. Believe me, I really want to do that, right? But that is going to make this training not for the 3 weeks, but maybe 4 or 5 weeks. But here is the thing, on the BridgeWire, on my website, right? I have most of the thing explained in pretty detailed manner. Believe me, this VRF alone, whatever we are going to cover in 10 minutes here or 20 minutes, it is explained in 1.5 hours, because this is an important concept when we talk about MPLS. And it is again a standard concept in any organization. Most of the organization use VRFs, right? But what is this? VRF is virtual routing and forwarding. It is a virtual router inside a router. So suppose if I have this router, a big router, I have drawn it a little bit big. I wanted to show you this is a powerful router, right? If I do not do anything, then of course, suppose this is my FA0/1 interface. If I see, if I configure an IP address, maybe 1.1.1.1 here, you are going to see a route here that 1.1.1.0/24 is actually directly connected with FA0/1 interface, right? This is known as global routing table. What is the meaning of global routing table? If you do not do anything, Every interface is part of global routing. Only one routing table we have. But can we have multiple routing tables just like the switch example which we had, right? And of course we can have. I have created two different virtual routers here. One is orange, one is green. And I have configured that interface number FA0/2 belongs to orange virtual router and FA0/3 belongs to green virtual router. It is as simple as that. And without any surprise, you can see there are two more routing tables inside this table, which is virtual router number 1 table and virtual routing and forwarding number 2, right? We call them this as a virtual router or VRF, virtual routing and forwarding instance. Number 1, this is instance number 2, VRF1, VRF2, and you can straight away see that FA0/2 is directly connected to me here, right? This is the route table for the orange VRF. This is the route table for the green VRF. It is as simple as that. But what is the use case? Why do we want to do, why anybody wants to do that? This is on the similar terms that why we are creating the virtual switches here. But there are so many use cases for that, right? Believe me, I can run one OSPF for global routing table, right? One OSPF for VRF2, one OSPF for VRF3. But because now these three routers are different, blue, orange, and green. Interesting, right? So I would take a pause here. Anybody has any doubt with respect to virtualization? Please do ask. Mr. Dhaval, do we have any question?
Nope. Everybody is quiet today.
Okay. But Dhaval, are you getting something out of it? Means if you are listening,
Yes, Vishnu.
you already know
It's
all
the
the
basics.
things.
Yeah, they should know the basics.
Yeah.
Yes.
So, okay, let's move ahead. But before that, I would like to take a hand raise, and whoever is going to raise hand, I will ask a question. Who has got everything from this virtualization board? Okay. Is this concept clear, everybody? Okay, I see only 3 hand raise. It means, okay, people are, this is good. This is good. Okay, so let's talk today with Mr. Hemant. Hi, Mr. Hemant. Hemant Raj, how are you?
Good, sir. How about you, sir?
Good, good, good. So, Mr. Hemant, are you fascinating about these concept virtualization? Do you feel
Yeah,
that this
yes,
is
sir.
good, or do you know about this concept in advance? Means आपको पहले से पता था, Mr. Hemant?
No, sir. Basically, I learned virtualization on what you have taught in a fourth slide. That is, but I have not heard about the virtualization on router.
But what do you think? Is this a fascinating technology? It can change the world.
Yeah, definitely. Yes, sir. Absolutely.
It is changing the world. So basically, if you see the cloud and everything, totally based on this principle, virtualization. Because
Yes.
on a one single server, on a one powerful server, they are running a lot of server of different organization. Okay. So if you feel this is good, please talk. And there is a company, if you have heard about VMware, right, which is acquired, but I think
Yes, sir.
AMC.
Cloud based.
Yeah. So there's a total company which is which was doing all these things. The company name was VMware. So having said that, this is good. Nice talking to you, Mr. Hemant. We'll
Thank
come
you, sir.
to okay, now there are some cool things, right? Now we are explaining again your home network or the small network or the bigger network, because this concept of DHCP, Dynamic Host Configuration Protocol, right? It is for everybody. It is actually everywhere. Okay, let's talk about it. So suppose you are sitting at your home. This is your router. This is your Wi-Fi router. And you must be thinking, I do not have switch at my home, right? Interesting. Let's see your Wi-Fi router. If you just check your Wi-Fi router at your home, it must be looking like this, some antennas, right? And if you see here, there must be 3 or 4 ports, right? And then basically we have one more port where they write internet. Believe me, guys, this is a router cum switch. The 4 port which you see is here, which they also say LAN. This is your switch. And basically, this port which is calling it there the internet, this is your your interface towards the internet. So what actually it is doing? If you connect here, you get the IP address in the range 192.168 dot something, right? Maybe X. And here, your router, this interface is going to get some public IP address from your service provider. Maybe that is, say, 8.7.6.5, suppose. So what this device is actually doing, this device is connecting to different network. One is your LAN, the other one is your WAN. Those are totally different network. But yes, instead of having this LAN, this device is capable of sending signals in electromagnetic or the radio waves, whatever Anumol suggested at that day. And your device is capable of doing the wireless, and that is why, but you connect to this LAN, that wireless is again a LAN. But believe me, if you connect your laptops directly into these ports, these laptops are going to communicate with each other without the help of this another thing, right? But if you want to go to anywhere else, you need to have this internet connection. This is very, very simple network, whatever we have right at our home. So what I'm doing here, I am having this router, I am having this switch here. Okay. And now what happened? I have this laptop number A, and I have connected my laptop with this Ethernet cable to this switch. Now there are two ways so that you can connect to the internet. First thing first, you log into this machine, give your username password, right? And start configuring TCP IP. Start giving IP is this, right? Your subnet mask is this, and your gateway is this router 10.1. Suppose if there are 100 of such devices, or maybe 20 of such devices also, you do not want to do this, right? Going into every laptop, opening it and giving it all these parameters which are necessary, right? So what need to do? What we have to do? Suppose another guy came here, and if you do not want to configure the IP address manually here, what should be the IP address of this guy? How this guy or how this laptop is going to know what is my IP address? Who is my default gateway, right? Somebody should help him, right? You must be thinking that I can help. I can manually configure it. It's pretty easy. I agree with you, but you cannot do for thousands of machines because this network, the same network, whatever I'm talking here, I'm talking here from your home network perspective. But believe me, I will show you in one of the slides that this is equally applicable. This is equally applicable to the bigger networks also, right? Because I don't think you ever configure this TCP IP address manually on your laptop, right? If you come to Cisco, you connect to the Wi-Fi and all should be good. But believe me, your MacBook or the Windows machine, Windows laptop, whatever you are working on, gets the IP address. If you not configure it, if you do not configure it, somebody else is doing on your behalf, right? And that somebody else is actually DHCP. There is a server. There is a server in your network who is doing that. But you must be thinking, no, Mr. Vishnu, there is no server in my home. There is no DHCP server in my home. The full form of DHCP is Dynamic Host Configuration Protocol. Means you do not want to configure the IP address here statically. That is why dynamic. What it will be doing? It will be doing the configuration of host, right? And that is why dynamic host configuration. Why this protocol? You all know protocol means some rules through which the server is going to behave. That is why dynamic host configuration protocol, right? And you can argue with me, Mr. Vishnu, I do not have any server which is working as DHCP in my home. I do not see any machine like DHCP. Nobody has given me this machine. And that is what I would say, that you have only one device at your home, which is this router. Believe me, this is also working as DHCP, Dynamic Host Configuration Protocol. How it works, it is going to be very, very interesting, right? For now, I am just taking this DHCP server out from your Wi-Fi router and placing it here, right? Let's see this. In the next board, I have literally written, this is interesting, that, okay. Here you go. Concept of DHCP, right? So now I have included one more server right here. And this server, believe me, it is going to help these machines getting their IP address. But how? How it will work? Let's see that. Because, and believe me, we all have understanding of address resolution protocol. We all know how layer 2 packets are going to be forwarded, how IP works, and everything else is working on it. Believe me, in computer science, if you know how transistor works, and before even transistor, if you know how AND, NOR, NOT gate work, right? Because on the basis of these gates, we have the most important invention, which is the transistor. And after transistor, we are making integrated circuits. And basically, these integrated circuits are nothing, but they have evolved as your CPUs. So this simple logic of gates, NAND gates, NOR gates, OR gates, have become CPUs, right? Similarly, if you know the nitty-gritties, the fundamentals of networking, like how communication happens at layer 2, how communication happens at layer 3, all these things are actually just an extension. So I would say just start thinking about physical layer, network layer, everything in data link layer, network layer, right? And just try to think how the packet is going to forward it. What exactly happening with this packet on a particular layer? If you see that, your networking knowledge is going to be tremendous, right? Having said that, for now, let's talk about how these machines are going to get the IP address from this new identity, which we have having here, the DHCP server. So this guy comes online. You switch on your lid of the laptop, right? And this guy is connected to 0/1 port of the switch. Here we have 0/2, 0/3. Suppose this is 0/4, right? So as soon as it comes, right? So we have two things here. We have DHCP server here, and believe me, your computer, you do not need to have to do anything. If it is running TCP/IP, it comes with the DHCP client. The meaning of client is just nothing. The meaning of client, that you have some piece of software written, right, in this router. Somebody else has written on behalf of you, and that piece of software is DHCP client. When you switch on this lid, believe me, this client on your machine wants to send a message. This is known as discover message. Through discover message, it wants to discover basically where my DHCP server is, right? And this message is broadcast message. Interesting. What is the meaning of broadcast? The meaning of broadcast is when the switch receives at this port, it is going to send it here, here, here. Who is going to understand it? Because this is a DHCP client, right? Only DHCP protocol can understand it. If your router is going to run your DHCP, then it is going to run. But I'm presuming I'm not running DHCP on router. I'm running DHCP on this server. So the packet reaches here. Router will say, no, I don't care it. What you want to say? This guy is saying, no, I do not care it. What do you want to say? But this guy is saying, okay, there is some DHCP discover message. Somebody is there who want to learn IP address. It is as simple as that. If that is the case, then this guy, the DHCP server, replies with offer message. And it says in this offer message that I am ready to give you this IP address. Interesting, right? This message can go here. This message is the unicast message because now the server knows what is the IP address. Sorry, what is the MAC address of this host, right? Switch can forward on the basis of source address, and the packet reaches here. This guys understand that yes, there is a DHCP server who is offering me, right? Interesting. Discover, offer. Third thing is sent by this machine, which is request. Now, basically, this machine is saying, I am requesting, right? That is perfectly fine. You want to offer this address. And basically, in this offer message, DHCP server is going to say that you can have this IP address, right? You can have this subnet mask, and this is going to be your default gateway, which is 10.1. Interesting. Then who has configured the DHCP server? Of course, you, right? If you open your Wi-Fi router, just see the setting of DHCP server. Somebody has mentioned that this DHCP server can assign IP address from 10.10 to 10.254 because this network is 10.10.10.0. It is as simple as that, right? Somebody has configured the DHCP server because DHCP server, you need to inform what IP address you want to give to these guys, right? To these laptops. It is as simple as that. And you need to specify too what is the default gateway here. And instead of you manually configured, you get an offer message. And now client is sending the message number 3, which is the request message, where it is formally saying, okay, boss, okay, Mr. DHCP server, I can use all these parameters, whatever you are sending, IP, mask, and gateway, I can use them. Definitely, I can use them. The number 4 thing is, server has get this request message. So by this message, it came to know that, okay, the client is ready to, and it is just acknowledging it. Done. 4 messages, everything is done. This guy is successfully able to get this, right? And this DHCP server stores this entry that it has already, maybe it has given this IP address 10.10.10.10 to this host, right? And it will store this entry into here that I have already provided this IP address. Now somebody else, host B, comes up. He is opening the lid. Now that the client here also already implemented along with the TCP IP, it is going to do the same process. Discover. It will be sending maybe the next IP address 10.10.10.11 with the subnet mask /24 and IP address, the gateway .1, right? So instead of you configure it manually, DHCP server is going to do, right? And that is why once you open the lid, these things happen. And now you can start communicating with the internet. It is as simple as that. So what do you need here? You need to define that what IP address range this guy can give. And the second thing you have to do is here, you need to define the default gateway also, right? And that is what we are going to see in the next board. How to configure the DHCP server, concept of DHCP, right? Very, very simple. But now what I want to do is, because most of the time we are not going to have these servers, right? Even our home network, we are configuring this DHCP on this wireless router. This wireless router, as I proved, this was a switch, this was a router, and this is a DHCP server also. Interesting. What I need to do, so first thing first, I need to define the range. So basically, I am configuring DHCP server on this router. I am going to say that Mr. Router, you can assign IP address from 10.10.10.0/24 range through this command. Network 10.10.10.0 here, right? This is my pool of IP address. I am also saying that specify 10.10.10.1 as the default router, right? And I do not want that anybody can get 10.1 IP address, right? Because 10.1 IP address is the router's IP address. This DHCP server will, I do not want that this router gives this DHCP, means this address to anybody else, because this is already my address. It is going to create problems, right? And that is why I have excluded some of the IP address from this router's DHCP server so that it cannot assign them. And those IP addresses are starting 1 to 9 IP address. I do not want to give them because I can use them for anything else, just like my default gateway, my HSRP, or so other things, right? Generally, I do not give starting 5 or 6 or 10 IP address to anybody, and that is why I exclude them. I tell them, Mr. DHCP server, do not use these IP addresses. I want to preserve them for future use, and the first IP address I've already used is for the router gateway, and the other IP addresses you can use, means from 10 to whatever this range says. It's a straightforward configuration, right? Again, that process of discover, offer, right? Request and acknowledgement happens here. People say that you can remember it with DORA, D-O-R-A, if you want to remember, but I don't think that you should remember it. That's okay. Internet is always with you. But yes, with respect to some certification, sometimes we need to remember it. That's okay. So now let's take a poll once again. Who get the concept of DHCP servers? Please raise your hand. This is perfect. Let's talk to somebody now, right? And this time, let's talk to maybe Simran, Simran Panda. Simran, can you hear me?
Yes, Vishnu, I can hear you.
Perfect. So Simran, did you get something out of this board, DHCP?
Yes, Vishnu, absolutely, I got it.
So is it, means now you can basically see that what your router is capable of doing, the home router itself, right? It is assigning the IP
Yes.
address. So I would suggest everybody, including you, right? Just open today your wireless router. Just try to understand what the configuration you have given there, right? DHCP, what is your public side IP addresses and so on, right? Can you do that, Simran?
Oh, okay, Vishnu, I will definitely try it.
Perfect. But this board makes absolutely sense to you, right?
Yes.
Thank you so much. Let's talk about next. Again, another topic, DNS. And this is very, very interesting. When I was reading about DNS, right? I thought this is very, very simple thing, which it is, right? Which is solving a very simple problem for us. But when I went into nitty-gritties of DNS, I find that it is a huge topic. Many people were contributed in building this DNS server because it is solving a big problem for us. What was the problem? The problem was, suppose we have a server right here, and we are pretty good with respect to DHCP. All these guys have gotten the IP addresses here. And by the way, in the previous board, I would definitely like you to contemplate on something, right? If you can just start thinking about it. There is a question for you, right? I'm not saying you need to answer now. I'm just saying just start thinking about it. Suppose I said that there is an initial discovery message, right? There is an initial discovery message. This guy, when this host comes up, it is going to send the initial discovery message. How come this host send a message, right? Because you all know that we are going to have first thing first IP packet, right? Maybe some data. By the way, your DCP protocol runs on UDP, and there is some data which say this is the discover message, right? And then I'm going to include this in the L2 header where the source address may be my MAC address a.a.a, and the destination is going to be all FY because it is going to be my broadcast message, right? And here's the question for you, for anybody who is sitting here, right? If I do not have the IP address at the first place, how I am able to forward this message on this interface? Interesting question, right? Right? I would suggest just write on internet packet capture for DHCP message, right? On the internet, you are I was really literally thinking about it, that to showcase you all these packets, but believe me, we have some time constraint. I cannot do that, and that is why this exercise is for you. It's up to you if you want to do that, but if you do that, it is going to be really, really good. So just ask for the DHCP packet capture and install Wireshark application. Once you install the Wireshark application, open this packet capture here to know what is going to be the IP address, right? It is going to be very, very interesting discussion, because all the times whenever you see that you are going to have the IP address, and here too, we are going to have the IP address. But what those IP address are going to be, I can tell the destination IP address. We will be sending this packet to 10.10.10. something, right? But how I came to know about this number 2, we have to see, right? Maybe both can be 0.0.0, but you have to see this, right? Just have a look at this packet. It is going to increase your knowledge. Having said that, let's talk about more why behind DNS, and then we are going to take the break. Why behind DNS? This is just a name here, right? So we all are comfortable in talking to you with everybody with the name itself, right? If I say Mr. Aditya or Aditi or Mr. Dhaval, it is good. Suppose if I say instead of Aditya Kumar Sinha, I say you are 10.10.20.30, or if I say Mr. 10.10.20.30, can you speak? It's a problem, right? We can't deal in numbers when it comes to name when we want to talk to somebody, right? Human is more friendly in remembering the name and not the numbers, right? And that is the main purpose behind it, that if you want to communicate, if this machine wants to communicate to cisco.com, right? And cisco.com is an IP address of 1.1.1, say 10.30, suppose. And if I need to remember this, that I need to talk to 1.1.10.30, this doesn't make much sense, right? So I say cisco.com. So there must be somebody who has given all these namings, right? The meaning is that there must be somebody somewhere has written that cisco.com means 1.1.10.30, or 1.1.10.30 means cisco.com, right? Actually, this is your DNS server's job, who is having all these entries, right? Interesting. I do not know how many hosts we have on the internet. Cisco.com, Bridgewire.com, Amazon.com, so many companies, right? Maybe 1 billions of such name, or maybe more than that, right? Do you think a single server can do that? I don't think so. And if a single server can do that, what I need to do, right? The first thing first, there must be somebody who is actually taking care of this, right? So when I write cisco.com on your laptop, it cannot communicate with cisco.com, and the reason is, to actual communication it needs to generate the IP packet, and IP packet understand only source IP and the destination IP, right? In the destination IP field, if you can give cisco.com, it is not going to work because you need to give the IP address corresponding to cisco.com, and that is why we have a server who can do all these things for us. And believe me, your DHCP server were giving this information about the server. Suppose this server, DNS server, who is having this entry cisco.com is 1.1.10.30. Its IP address is suppose 8.8.8.8. So your DHCP server was providing a lot of information to us. What information? What should be your IP address? What should be your mask? What should be your gateway? And it's also specify one more information. What is your DNS server? Why? Because DNS servers is really important to know the IP address corresponding to cisco.com. So when you write cisco.com in your laptop, what actually happens? A packet goes toward this server, right? How you come across this 8.8.8.8? Because DHCP server informed you that your IP address is this, mask is this, gateway is this, and that your DNS is this, right? So if you want to communicate to anybody on internet with the name, first thing first, go to this server. This server is going to give you the IP address corresponding to this 8.8, IP address corresponding to cisco.com. Why? Because this DNS server has the entry for it. It is going to give you this IP address, and now you can create this IP packet and send the packet across. It is as simple as that, right? So if I show you in the next board the concept of DNS, your DHCP server, which was a router, maybe he has given this guy that your IP address is 10.10.10.20, your mask is /24. If you want to reach to internet, come to me. My address is 10.1. I am your gateway. And along with that, here is your DNS, which is 8.8.8.8. If you open a browser and if you write here, www. say amazon.com, say, computer doesn't understand what is amazon.com. The first thing first, it will try to convert this amazon.com into the IP address. So the first request after you get the IP address from the DHCP is going toward this server, because you know the IP address of DNS now, and you ask him literally, who is amazon.com? What is the IP address corresponding to amazon.com? And it will be replying you. Once it is the case, you can communicate to internet. It is as simple as that, right? We can combine all these things together, but we are going to combine them when we comes back. It is going to be 10 minutes discussion. Then we will be talking one important security piece, which is DHCP snooping, and then QoS, right? Having said that, I would like to take a pause here. Welcome back once again, and we are into this board. As I mentioned, that we will be combining whatever we have learned till now from this in this diagram, right? As I mentioned that this is the most common question. What happens when you write cisco.com in your browser, google.com, amazon.com, or maybe bridgewire.com in your browser, right? So believe me, we have spent around 36 to 38 hours till now in this CCNA course, and we have gathered a lot information. So as I mentioned that if we are new, then this can take around 2 to 3 hours, but I can sum it up in just 10 minutes, that what exactly happens. So first thing first, when you come to your organization, maybe inside Cisco, or if you are at your home, what you do, you just open the lid of your computer, right? But what is happening behind the scene? As soon as you do that, here is the client, which is known as DHCP client. You all know about it now. It will start doing its work. right? What it is going to do, it is actually finding your DHCP server so that it can take the address from there, right? The complete offer, discover, request, and acknowledgement message happens. And at the end of the day, your device, first thing first, will get the IP address. Suppose you are in a VLAN, which is 10.10.10.0/24. So you are going to get this IP address, maybe the first IP address, which is 10.10.10.10, which is allocated to this DHCP IP address, sorry, DHCP server, so that it can allocate you this. It is going to say that you are going to have the mask/24. It will also inform that you will be having the default gateway of 10.10.10.1. And then at last it says that the DNS server, which can resolve names for you, is going to be 8.8.8.8. Interesting. This is the thing. These are all the parameters comes to your laptop when you open the lid. This process is fast, right? Interesting. So first thing first, when you open the lid of the laptop, it happens, you get the IP address, and now you suppose open this browser. When you open this browser and write cisco.com right here, right? You want to browse. It means that you want to connect to TCP port 80 of this server. The server is present somewhere on internet. Maybe the IP address, let's say, is 1.1.20.1. Suppose this is the IP address of cisco.com, right? And the browser which you are using, it's again a client, and here we are running server. And your client, this browser, wants to connect to TCP at port 80 because you are running this cisco.com website on this server 1.1.20.1 on port 80 of TCP. This is not UDP. UDP we can use in case of real-time systems, right? Why real-time? Because it doesn't matter that if we lose some packet there, because it doesn't matter, do we want to retransmit them? No. But TCP, if we want to, suppose if you are just clicking or want to access google.com and google.com does not send that search bar for you, you will be pretty amazed to see that what is happening, right? That means that you want all the contents to be delivered to you. And if something remains there, if something is missed at the IP layer, it should be retransmitted. And that is why we are using TCP and not UDP to access your port 80, right, on the cisco.com. But here is my problem. The problem is if I have cisco.com, I do not know the IP address associated with cisco.com. This is the big problem. Why? Because your complete infrastructure is running on IP protocol, and IP understand IP addresses and not names. And that is why your first request is going to go towards this DNS server. We have just talked about it. Who has provided this IP address 8.8.8? DHCP server, right? DHCP server provided this IP address so that you can resolve the IP address. You can resolve this name to a particular IP address. This is actually going to be your DNS request. Believe me, interestingly, this DNS request actually, when we have the DNS, when we do this, your IP packet, whatever you want to say, it is not going to be generated unless you are resolving this, right? So basically, the DNS request message will be created at this system. It means that you have DNS client here, right? So many clients are working on your little laptop, right? So this guy say, who is cisco.com, right? This is your actually query from this client. And if this is a client, you can all presume that all the client need coding to be developed, right? DHCP, DNS, they are part of your application layer. So DNS is here, right? DHCP is here, right? Some client, right? So somebody has created this cisco.com, that what is the IP address along with the cisco.com, and now it is your responsibility of this network to send this packet to 8.8.8.8, and definitely you can say, right? But you need a protocol which can send it, and DNS also use UDP protocol at port number 53. Who is listening at port number 53? This guy. This guy is the DNS server, right? When you make this guy a DNS server, it start listening at port 53. So the first packet which comes out of your machine is going to be your DNS message from here to here. And if you want to send it, it must be encapsulated in IP packet. And of course, you are going to have the IP address of this machine 10.10. Destination will be 8.8.8.8. And now you all know that how to forward this message, right? You have the default gateway, everything, whatever you have learned till now, address resolution protocol for this default gateway will be there. And then you come to know about the MAC address. Your source MAC address is A.A, destination MAC address of this router may be R.R. Although hexadecimal number does not have R, but let's take it R.R.R. So the first packet which comes out of your machine is the DNS message, because you want to resolve this name into an IP address. This packet will be reaching here towards your router. Router will be routing it towards the DNS server. This is going to be a DNS request. DNS request will reach to DNS server at port 53, and this server is listening at port 53, and it is going to reply back from here to this machine. This is going to be a DNS reply. Believe me, I am oversimplifying the DNS process. If you want to read, I can suggest a book, or just wait for my another video which is in the creation, right? How DNS work. So basically it is going to be 1 to 1.5 hours of video which I'm simplifying this complete process for you, but here I am hiding a lot of information. Only 2 packets: DNS request, DNS reply, UDP messages going out from this machine, reaching to DNS server. The DNS server is replying that Mr. Laptop, Cisco.com is actually 1.1.20.1. It has this entry. How come it has this entry? It's a big discussion. How come this DNS knows all the computers in the world, all the name of the computer? It is a big discussion, right? And there is a hierarchy. If you want to understand that, just wait for it, for my video, or there are tons of book available on internet, right? Now this guy knows what is the IP address corresponding to this machine, right? Which machine? Cisco.com. And now it can create the packet, right? It is going to create the data. Suppose it is asking for GET request. It is sending the GET request. This is the data generated by the application. Which application? This browser. This browser is going to generate this data that I am sending a GET request to where? Cisco.com. And now this is going to be encapsulated into TCP header. Why? Because we are going to use TCP, and we are going to towards port number 80. Why? Because Cisco.com is running at port 80. And after that, I will be encapsulating into the IP header, right? For IP, everything else is the data. And I am going to write that now I want to go to 1.1.20.1. My source address is 8. My source address is 10.10. And then again, I will be encapsulating this into the frame, and the frame is going to be having source MAC and destination MAC. You know the destination MAC is going to be the router. Why? Because you are going to communicate outside your VLAN, outside your network. And if that is the case, you need to go via router or the default gateway, which is provided by the DHCP. See the pieces which are working together. First thing first, when you switch on your laptop, when you open the lid, DHCP comes into picture, right? To be precise, DHCP client comes into picture to get the IP address. The second thing is it is going to be the DNS which comes into picture, right? Try to understand. DNS, DHCP work on UDP protocol, right? Then when DNS resolve the IP address, now you have a complete packet and you know how to forward it. Your switches, routers, hop by hop, send this packet towards the cisco.com, and cisco.com is going to get the request, which is get request, right? And whatever is in this get request, it is going to reply, and that is how your browser is going to showcase you the content of cisco.com, right? Just try to understand how many pieces are here. If anybody wants to ask, anybody can ask anything, right? If you say that basically DNS packet are going over UDP, then they can totally ask, what is UDP? Now you know that, right? Then you must be saying that TCP is another protocol. And believe me, TCP is a huge protocol. In this question itself, if you are explaining to anybody, right? They can ask you TCP also. What is this TCP? Then you must be saying that I need to send this to a router and I need to do ARP, right? Then they might be asking, what is ARP? Then you must be thinking that the router is going to send this packet hop by hop using the routing protocol. What is routing protocol? What is routing table? This is entire networking, right? If you know all the pieces, then you are few steps away. Just make this network redundant enough, right? Because nobody wants that if this router goes down, then you are not able to access it. And whatever we are doing on top of it, we are just increasing the efficiency of the system. We are just increasing the redundancy of the system, right? And it is not the case that we were not able to do the WAN. WAN was already there, wide area networking. Then why do we have SD-WAN? Why? The reason is we are actually improving the existing WAN using softwares. Again and again, I'm saying one thing: if you have solid background, if you have solid fundamentals, you can learn any networking technology on top of it. These are the things which are absolutely mandatory to build the solid base. Having said that, let's move to the next board. If you have any doubt, any question, Khushi Chaube, do you have any question? Because I can see the hand raise.
No, actually, Vishnu, I previously raised the hand to.
Okay, that's perfectly fine. Okay. Let's move forward. And we will be talking about, now let's see what is happening inside my organization. We have discussed till now your home network, how DHCP DNS working there. But let's try to understand that this is the requirement at the organization level too, right? This is the cisco.com office, or sorry, Cisco's office. We are in building number, maybe here is my campus. We are sitting here. This is building number 11, maybe 12, maybe 13, maybe 16. I do not know where you are, but this is your campus. You're sitting inside this campus and you come up with your laptop, you open the laptop. Don't you think the same process is going to happen? Because you are not going to configure the IP address. You are not going to define the DNS server, right? Interesting. But this is your campus. Don't you think that if I am connecting to a particular switch, then I just noticed that if my laptop is here, my DHCP server should be here. It means that if I have 10 VLANs, I need to define 10 DHCP server? No, absolutely not. There must be some way. For example, this branch is in, maybe say in Delhi, this is in Bangalore. If this guy wants to have IP address automatically, what do you suggest? Shall I have one more DHCP server? For 1000 of my branches, shall I have 1000 DHCP server? Just try to understand the problems, right? Or maybe a particular branch can have multiple VLANs. Your campus is going to have maybe more than 30 VLANs. Suppose if that is the case, do I need to have 30 DHCP server each and every VLAN? Because I know that when this guy comes up, it is going to send the broadcast address and it is going to send the broadcast message, which is the DHCP discover message. And you all know that the DHCP discover message cannot go outside my VLAN. And if that is the case, it is a problem, right? I need to have DHCP server every VLAN, every office, which is not looking the very promising solution for me. And you all know that we have a data center also, Cisco's data center somewhere. And it is the requirement that we should all place all the servers here. So some intelligent guy came and he suggested, no, I do not need 2000 DHCP servers. I am going to create only one DHCP server inside my data center. Interesting. But here is the question. If this device comes up, he opens it lit, it is going to send the DHCP discover message. Discover message is going to be the broadcast message. And you all know routers cannot take a broadcast from a particular network and deliver it into another network. Router breaks broadcast. I'm not saying routers cannot generate broadcast message. Of course they do. They can generate address resolution protocol message, but they cannot take address resolution message from one network and forward them into other, right? They cannot do that. It means I do not have DHCP server in my campus. How these guys are going to, or the particular VLAN, how these guys are going to get this IP address? Because my DHCP server is there in the data center, right? But I have the communication, means I have created this network. I have this WAN network up and running. I have these all switches and routers up and running. I can reach to DHCP server, but here is my problem. DHCP discover message is address resolution, sorry, broadcast message, which cannot be forwarded by this router. And that is why I make this router do some magical things, right? This is absolutely, we are absolutely sure on that if this router is connected with this network, and if somebody is sending the DHCP discover message, it will be reaching to this router, because DHCP discover message is actually the broadcast message, and router is connected to this network and it is going to get on this interface. So this router is going to get this DHCP message for sure, right? But it cannot forward it. So what we do is we configure something called relay. And you all know the meaning of relay. The meaning is a router takes the ARP message. It is a broadcast message. It will convert this broadcast message into unicast message using IP and forward it towards your DHCP server. But you need to make sure that this router knows where is my DHCP server is. And that is why I am logging into this router and I am saying that I want to make you relay. Relay for what? So that you can get the DHCP discover messages, make them, forward them towards 10.100.10, but not as an ARP message, sorry, not as a broadcast message, convert them to the unicast message, and then this message can go to the DHCP server and DHCP server can reply back with the address. It is as simple as that. We call this as DHCP relay. Why it is important? Because we do not want to have many DHCP servers per VLAN. And I am specifying here 10.10.100.10. What is this? This is the DHCP server address, IP address 10.10.100.10. It means that the router, or consider this branch also. In this branch also, I have configured this command that for you, the DHCP server is this one. So when this guy comes up, it is going to send the DHCP discover message. This guy will be converting that broadcast discover message into the unicast message. Unicast message is going to have the destination IP address, which is 10.10.100.10. What is 10.10.100.10, right? This is your DHCP server. The message will be flowing here, and this guy is going to reply back. It is as simple as that. This was your DHCP relay. I would like to take a pause here to understand that you get this concept, right? Just please raise your hand if you know the answer, means if you understand the DHCP relay and the previous board. And I could see that there are hand raises, right? So let's talk to somebody, right? Here we have, let's talk to Gautam Krishna. Gautam, are you there?
Yeah, Krishna.
Hi Gautam, how are you?
I'm good. How about you?
Good, good. So how are you feeling? Your CCNA class is going to be end today. Maybe a relief?
Not really. Like there are more to learn, right?
Yeah, there are more concepts to learn. But does this board, the DHCP relay board, make sense?
Yeah, it does.
Okay, perfect. Okay, then let's go. So you can lower your hands, everybody. So this is going to be the second last topic of today, DHCP snooping. Okay, and this is going to be very, very interesting case because we are introducing somebody who can disturb your network. You remember that attacker, right? The intruder. But before that, just understand that this is just the name for you now, right? Let's understand the problem, that why do we need one more name? We were good with respect to dynamic host configuration protocol, DHCP. What is this DHCP snooping, right? By the way, you can Google it, Google the meaning of snoop, right? Means basically you are getting some information secretly, and that is what snooping means, right? But why do we need it? So suppose we have a network, and if I draw this network, you must be understanding that Vishnu is talking about layer 2 network, right? Why? Because we have switches here, right? We have switch here, we have switch here. And suppose we have 4 hosts here. Host number A, B, C, and D. It is as simple as that, right? What is going to happen? Suppose this guy comes up, he has opened its lid, right? He's sending DHCP discover message, and I am taking an example where DHCP server is right here into its VLAN. Everybody, the green, whatever we have, the green laptops, those belongs to the same VLAN, maybe VLAN number 10, 20, whatever, right? So this guy is sending the request message, sorry, the DHCP discover message. And of course, this discover message will reach to DHCP server. DHCP server will be replying the message, right? And this guy is going to get the IP address. As simple as that, right? But suppose somebody has created another network. Guys, just wait a minute. I think I'm not. Dhaval, I'm audible now? Anybody can confirm?
Yeah, Vishnu.
Yes, you're
Yeah.
audible.
Okay. So sorry for the break. So we are here once again. So if you can see that there is somebody which is part of my network, but he has some bad intention. He has created another server, which is the DHCP server, and it's a rogue server. Interesting. Now, suppose host D comes online. This guy open his lid, and what it is going to do, it is going to send the DHCP discover message, which is a broadcast message, right? And try to understand, because of the proximity, this message is going to reach to this server first. Because to reach to this server, it needs to pass to this trunk link, and then it can go like here, like this, right? Who will be getting the message first? Rogue DHCP server is going to get the message first, right? And here this guy can give the wrong information. Maybe the IP address wise it is correct that you can have 10.10.10. 20 IP address. Your mask is this one, but it does an interesting thing. He says your default gateway is 10.10.10.5. And interestingly, it says maybe there is another machine on this system, or maybe this machine, because your normal laptop can be the DHCP server if you can run the DHCP code on top of it, right? So this is the DHCP server you're running here, and it is saying that this machine who is having the IP address 10.10.10.5, it is going to be a default gateway, right? This guy is also responding, but the reply comes back from this rogue server first. And if that is the case, this is my problem. Why? Because this man who is in the middle is giving us some wrong information. What was my default gateway for this network? There was a router which is 10.10.10.1, right? And you can, and after this router, there is internet and everything, and you can go straight away like this from here to here, right? But this guy is saying, I am your default gateway. It means that whenever you want to go towards internet, you are going first toward this guy machine, and now this guy can take all these messages, whatever you are sending, right? Now it's up to him. He can also forward these messages towards this router so that you do not have any idea that your messages are going through one more machine which belongs to this intruder. This intruder can access of all of your packets, and if he's intelligent enough, he can do a lot of things, right? Very, very interesting, right? This man who is sitting with this DHCP server in the middle, right? In the middle of your actual DHCP server, it is creating the problem, and we call such attacks as man in the middle attack. I think you all have heard about it. If not, that is perfectly fine. Maybe somebody of you may want to go into the security domain also. Believe me, really, really interesting topic. And the important thing is, see, if this guy can think this much, then he can take all of your packets. Then there must be somebody who must be working on these type of attacks, right? Who must be removing these type of attacks from your system, right? And that something is this technology known as, or the feature known as DHCP snooping. You can configure this feature on these switches, right? Let's see the logic of this feature. So first thing first, do you guys understand the meaning of this man in the middle, right? What it can do? DHCP job role was to assign the IP address and then basically the default gateway. But now here, there is another DHCP server, which is a rogue server by this intruder. He is assigning the IP address. IP address is correct, but not the default gateway. He is getting all of your packets, and once it inspects those packets, it sends to the default gateway, the actual default gateway. And believe me, the intruder is not always outside your organization on the internet. Intruder can be anything, right? Maybe this employee is not behaving, right? He has some extra skills and he can do that, right? So having said that, let's talk about through which feature of the switch we can just eliminate such kind of attacks, right? So basically through this feature known as DHCP snooping right here, we can do some magical things, right? So basically we need to enable this feature on these switches, right? This switch number 1, and the command is very, very simple. You just say in the configuration mode IP DHCP snooping, right? Similarly here on this switch 2, By default, when you enable this feature, which feature? IP DHCP Snooping, by default, it will put every host of the switch. Suppose this is 0/1, this is 0/2, this is 0/3, this is 0/4, 5, and 6. Every access port of this switch is going to be untrusted by the switch. What is the definition of untrust? I will let you know. But first thing first, I am just saying that this DHCP feature put everything in untrust mode, right? Untrust means that if a particular port is untrust or untrusted, right, it cannot receive any DHCP offer or acknowledgement. Very, very interesting thing, right? If you remember, we have 4 different kind of messages: discover, offer, request, and acknowledgement. How many of these were sent by the server? This was sent by the client, because client has to discover the DHCP server. Offer was sent by server, request was sent by again client, and acknowledgement was sent by server, right? So I am saying over untrusted ports, nobody can send offer and acknowledgement. If this device, if this switch receives an offer message from here, try to understand, right? Offer is always from the server. And if this is the access port and you do not know that this is on this access port, there is no server, then you won't believe these offer messages. You must be thinking that these are from the intruder, right? So by default, the switch presumes everybody as untrusted port. Nobody can send, this switch cannot receive any offer or request message or any acknowledgement messages from all these ports. It means that this rogue server, although this device can send the DHCP discover message, but when these rogue servers were replying the offer message, this switch is going to say, no, you are not a DHCP server, because all of my ports are untrusted. I do not believe you. And this offer message will not be forwarded towards the client. Similarly, the acknowledgement too. It is as simple as that. But you must be wondering that, Mr. Vishnu, you are right. This was my rogue server. If you are doing this for controlling the rogue server, that is absolutely fine. You just remove the man in the middle attack. But what if this DHCP server is the legitimate DHCP server? This is a correct DHCP server, right? And if this port is the trust port, then untrusted port, if this guy is sending the DHCP offer, even this switch is not letting it go, because this is the definition of untrusted, right? You just said. And that is why there is another kind of port in DHCP snooping, which is trusted port. It is as simple as that. So what you are going to do, you will make manually this port 0/3 as the trusted port. Why trusted? Because you actually trust this port. See, the definition of trusted and untrusted is different. Untrusted means you cannot receive offer and acknowledgement, but trusted means you can receive any message, discover, or send any message, discover, offer, request, acknowledgement. If that is the case, then 0/3 port will be receiving the discover message, right? This guy is going to send now DHCP discover, right? And offer definitely won't be coming from here, because this is the untrusted port I have. So this packet, because it's a broadcast, it will reach here. Let me show you the yellow color. It will reach to DHCP server. DHCP server is replying with offer message. Of course, 0/3, because it is a trusted port, it will let the message pass through and the message will be here. And your discover, offer, request, acknowledge message will be passing, and this guy is going to get the IP address from the correct DHCP server. Believe me, if you understand the process well, and that is what I wanted to explain, this complete package, the complete messaging system of the DHCP, so that you can understand that how you are going to mitigate or resolve this issue of man in the middle attack, right? Interesting. And this is my advice to you. It is going to be always the same, that if you understand the process, if you understand the protocol fully, then you try to think how to make some changes in it so that it becomes more efficient. And that is where you will be able to write patents. Once you understand it better, then you can think that there is a problem in the system and I want to improve it. It is as simple as that, right? So configuration wise, just write IP DHCP snooping in the configuration mode. Just go inside this interfaces, which whatever you feel trusted, just make it trusted, and that is it. As simple as that. Having said that, this is what I have. If I get some time after Punish session on the QS, I will be definitely letting you know that there is another concept, right? If the time permits, because Dhaval or Punish has talked about control plane as well as data plane. So I would like to have a discussion of 10 minutes on that. But if it is not possible, that is perfectly fine too. Because this is the important topic though, but you can read it. If you can read it, you can get it. No doubt about it, right? Having said that, this is what I had for today's class. And Mr. Punish is going to take control from here. Punish, is all up
Yep.
to you, man.
Thank-
The next
thank you,
topic is going to be quality of service. Very, very interesting topic. Just have a look at it. Okay,
Thank you,
Punish. So
Vishnu.
I am stopping the recording right now.